Hey there, kids. We are starting a new video. This is for lesson 2 in module 2. And the goal here, our objective, is to estimate multi-digit products by rounding factors to a basic fact and then using place value patterns. It's not complicated. It's actually kind of a fun lesson. We're going to be rounding numbers, and sometimes they won't really tell you where to round to. Like we have some practice stuff here that I like to make up, so I'll say round to this place. Notice that these numbers are all the same, 4271398, and I just said let's just round to different place value positions and show what would happen. This is kind of the way that I instruct my students. I'll say, well, the 1, 2, 3, 4, those are the small numbers, and if your helping number is a lower number, then you would roll it back to the previous 10, whatever it is. And if it's a high number in the helping place, like a 5, 6, 7, 8, or 9, you would roll up your answer to the next 10 by doing the just add 1. So I've covered rounding in a different video from a few lessons back. And when we talked about the vertical number line, that is the Common Core way. So it's basically just taking the number line and turning it and saying, all right, if we've got this midpoint, we're going to predetermine that a 5 goes up, just like it does here, and the 4s would drop you down to the previous 10. So looking at these, the numbers in the box, okay, if 71, this is the rounding place helping number, 1 is a little number, so you would roll that to 70. Everything else becomes a 0. Everything to the left doesn't change. So this is really just that strategy of 39 becomes 40. And then depending on what you get, if you round to this place, and this is a big bossy number and it says just add 1 here, look what happens when you just add 1. You get a 10, and that can impact yet another place value position. So really important to kind of watch out for how things will change. A few more samples down here. Let's say you've got a vertical number line. We're looking at where's the halfway point. The helping number is always going to be the number to the right. Okay, so if you're talking about the 10ths place, then it would be where does your number fall between 10 hundredths, 15 hundredths, and 20 hundredths. Well, if 13 is going to be between 10 and 15, so then you would roll it down to the previous 10. And then I have another example here, just using some of the distributive property that we were using in previous lessons. So there's a little bit more on this. It's just talking about the math language, knowing that a factor is something you multiply. The product is the answer to your multiplication problem. And you can also have the product or the answer come first and then have the factors after it. So you can switch them around. That's okay. And let's see, that's for the rest. And then I have a couple other little notes here. This one is kind of handy. It's actually more from the book. And it's, again, lesson 2, estimating multi-digit products, but the lazy way because I didn't write the whole thing out. And a few sample problems. For example, if you have like a 456 times 42, and you're really just looking to estimate and make it easy for yourself, I would always try to go to either 100 or a 10 that's close by. So if you're kind of in the middle here with the 456, you can look at what you're doing and say, well, if I round 1 up, can I go down? Some students will. And so if I take this and make it 500, and then I make this 40, so this one goes up and this one goes down, it will just make a little bit of a better estimate. Okay? You can then separate using the associative property, take the 5 and the 4 out, take the 100 here and the 10 here, and take those out, and then show your multiplication. Be careful when you have your 0 in your main product to count the correct number of zeros. Okay, if this is 20, then I have 3 additional zeros. It gets a little more challenging if they start throwing like an additional 10 on here and an additional 10 on here. So your final answer would then have 2 additional zeros. If this is 20,000 or 2 with 4 zeros, here's the 2 with 1, 2, 3, 4 zeros. Here are your 2 extra zeros. So you just have to be really careful when you're counting your zeros and rounding. And we'll have some options in our rounding. So those are your notes for today. And we'll go ahead and jump into the book. Lesson 2, Module 2. You can always tell what the module is. It's up here in the corner. And the lesson. And, of course, the objective is going to be at the bottom in very, very tiny writing. So tiny that I need my glasses to read it. So here we go. Round the factors to estimate the products. Now, sometimes it's actually just okay to have a rounded answer. Sometimes nobody cares about an exact answer. I know it's hard for kids to understand, but sometimes nobody cares. And so if you say, you're talking about large things like a TV is at $597, who would actually say, like, it's $597? I would just say, well, it's about $600 because, there's always going to be tax. But if I have to buy 50 TVs for a school and they're all about $600, I would just round that. I want to use something that is close to this without, like, straying too far. Then notice the wiggly equals. That means is approximately equal to, and I'm waving my hands here like you could see me talking, is approximately equal to. So then we're going to take our 6 and our 5 and we're going to multiply and get 30. And then we're going to take what we did in lesson 1, and if we have 100 here and a 10 here, we've got 1, 2, 3 zeros, 1, 2, 3 zeros that you're going to tack there on the end. So you have your basic fact, just like lesson 1, and then your 100 times 10. Don't forget all the zeros. You're just kind of counting the zeros after the basic fact. Watch out for the facts that have a 0 in the product already. So they're just saying round it to estimate a reasonable estimate. That means it makes sense and it's not totally far off. And notice that they just repeated everything, so you repeat your own answer is 30,000. Okay? So let's do another one. B. They won't make you repeat it too many times here. I think that's the only one. So approximately, if I have 1,103, I wish I had, that's another thing. If you want to write up here, just to remind yourself, I wish I had something that was easier than this. So I wish I had about 1,000. Notice that it's approximately. And then 59 is so close to 60, just bump it up. And then you can easily take your 1 and your 6 and multiply and get 6, and take your 1,000 and your 10 and count up those zeros, 1, 2, 3 from 1,000, and the 0 from the 10, and you end up with 60,000. Okay, so a reasonable estimate is going to be about 60,000. Now, some students will say, I know my 11s, and I know that 1,100 times 6 from the 60 would give me 66. And I'll say, hooray. I usually just say, good for you, like I'm happy for you. And again, when you're estimating, it may not, or it will not, or oftentimes there'll be like, which is the best answer? But you're really pretty close either way. The 1,100 is actually quite close to your actual answer. So you could always take all these and really multiply it out if you wanted to see what was closer, but they're not going to make you do that in today's lesson. So it's just get close. Is this right? Sure. Is this right? Yepers. So just get close and you'll be all right. Now, it starts to get a little bit harder when they give you something that's more in the middle, where it's not exactly an easy round, okay? So if I have 5,840, I'm kind of, I look at this and I say, well, 58 is pretty close to 6,000, so I can still round up, but I've had to go up a couple hundred, okay? Now, what do I do about the 25? It's right there in the middle. So let's think for a second about quarters. What if I was to just leave that there? Okay, what would happen? I would take my 6 and I would multiply it by my 25. Now, you might be going, oh, I don't know how to do this in my head. And I would say, I think you do, because 25 is a quarter, like a quarter that you put in a vending machine. And so if I have 6 quarters, well, 4 quarters makes $1 or 100. So 6 of them would make 150. So you really know more than you think you know. And then you take those 3 zeros and you tack them on the end. So in doing our basic fact here, you can stay quite close to the original factor with your estimated other factor and have a nicely estimated product. Now, what if you rounded things differently and you did 6,000 here and you did 30 because you decided, I'm going to round this up? Well, what would you get? 6 times 3 is 18. And then you would have the 3 zeros from the first factor and the 1 zero from the second factor. So instead of 150,000, you'd have 180,000. And then what if you just say, I don't know, I'm not quite sure what I'm doing. What if I round this up to 6,000 and then I round this down to 20? Because I went up so much, what if I go down instead? Well, 6 times 2 is 12. Then you take your 3 zeros, 1, 2, 3 from the first factor and your 0 from the second factor. And so you've got some choices here. Okay, it's a bit of a spread there. Okay, the difference would be the 60,000, but you couldn't necessarily say that you're really wrong. And if you had to argue this point, I could say, well, yeah, it's not too bad. Good job, good job. This one is actually the one that the book or the answer they want you to get, because they want you to realize that 25 can be left alone and you can use that like quarters. So think of that as money. So here again, we have to repeat our thinking. A reasonable estimate for 5,840 times 25 is about 150,000. We're just going to go with the middle one because that's where we use 25 as a factor. Okay, now for the bottom here. Complete the table using your understanding of place value and knowledge of rounding to estimate the product. So they give you an example. If I have the expression, remember an expression is just the numbers that are set up but no equals and no answer. That's an expression. See? No equals. The rounded factors are going to be, you can put little lines if you like to organize your work. Round it so that it makes sense. This goes to 3,000, this goes to 40. Take your basic fact, find the answer, and then 1, 2, 3, 4 zeros, 1, 2, 3, 4. So that's what they do for you. Now we're going to jump right in. Your rounded factors. 28,000 would be really close to 30,000. 420, we can go down to 400. Here's the 3 times 4 to get 12. Now count 1, 2, 3, 4. 1, 2, 3, 4, and 2 more. 1, 2. Sure, it's a lot of zeros, and that's a huge number, but it's okay. 12 million is the answer. Let's do another one. Okay, 8,900. Now notice we have been going down and rounding down and rounding down, but sometimes you have to go up. So 89 is awfully close to 90, so I'm going to have, instead of 8 in the thousands place, I'm going to have a 9 in the thousands place. Times, and instead of 59, I want to bump that up to 60. So I'm going to take my 9 times 6 and get 54, and then I'm going to count my zeros. 1, 2, 3, 4. 1, 2, 3, 4. And I have 540,000. Next one. So fun. Now, here's where they start putting in your unit form. So you have to think about what 890 tens would look like. 800 or 89 tens, I just gave it away. Okay, 89 tens would be 89, and then that's finishing in the tens place, so it's 890. But again, we have to round these numbers. How about 63 tens? 63 tens makes 630. So let's round these to our rounded factors, bump it up to 900, and pull this one down to 600. 3 is little, it goes down. 9 is big, you bump it up. 9 times 6 again is 54. 1, 2, 3, 4 zeros. 1, 2, 3, 4. 540,000, your final answer. Now here we have 398 hundreds times 52 tens. So once you put in your standard form number or factor, then we can round those. So 39,800, pretty close to 40. 39 would go to 40. Multiplied by, drop that down to 500. I almost put 5,000. I was like, put the brakes on. 4 times 5 is 20. Watch out for your basic fact. Then you have 1, 2, 3, 4, 5, 6 more zeros. 1, 2, 3, 4, 5, 6 more zeros. Then every 3, put your comma in because it will help you read your final answer of 20 million. All right, hopefully you guys are getting this. We have one more page in this lesson, and we're going to wrap things up. So, for which of the following expressions would 200,000 be a reasonable estimate? Explain how you know. Well, the explanation is going to be all about how many zeros there are. Okay, so if I have 1, 2, 3, 4, 5, I need 5 zeros. Okay, so that's going to be my 10,000s place. So I have to look at what's being multiplied. So I need 2 as my answer. So each time I'm going to use the factors that will help me get there. So it's going to be 2,000 times 10, because the 2 times the 1 would give me the 2 that I need. So you're estimating these kind of in your head, but then you're counting those zeros. This is going to be 1, 2, 3, 4 zeros. 1, 2, 3, 4 more zeros. So is 20,000 close to 200,000? So this one would be not a reasonable estimate because I'm off by a full place value position. Okay, so this one is too small. Next one, if I have instead of, now look at what they did here. They bumped us up into the 10,000s plus bumped it up into the hundreds instead of tens. Now if it was only small by 1 0, it was too small by 1 0, now they've kind of gone overboard. If I had 20,000 times 100, then I've got my 2, but now I have 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6. And that's too many because I only need 5. Too big. This one, they're leaving this factor alone. They drop this back to the first one, so it looks like this one's going to be our winner. 2 times 1 is 2, and then 1, 2, 3, 4, 5 zeros. There it is. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I can count. I'm a teacher. There we go. So we have our 200,000. This one's going to be just right. And look at this one. Again, it's way too big. It's even bigger than this one. You can just put too big. Okay, so it's even bigger than the one that was too big before. So looking at place value, I don't even have to solve it. It's got too many digits. Okay, now 4A. Fill in the missing factors to find the given estimated product. That means they gave it to you. Given means they gave it. So I need to make sure I can get 24 from these two factors. So what can I multiply to get 24? That's close to this. First of all, take 571 and you say it's pretty close to 600. 6 being one of my factors. And then if I multiply 6 by what? 4, I will get 24. Check your zeros. 1, 2, 3. 1, 2, 3. Okay? So I have filled in the missing factors to find that product. Let's do that again. That was so fun. So fun and easy. 726 times 674. I need to get 49 out of that. What numbers can I multiply to get 49? You're right. 700, this is going to go down, times 700. because 7 times 7 is 49. 1, 2, 3, 4 zeros, 1, 2, 3, 4 zeros, and now we've got our factors that we filled in. How about this one? I have 8,379 times 541. What am I supposed to get here? Am I supposed to get 4 or 40? Be careful with your rounding here. 8,379, I could round to 8,000. 541, I could round to 500. This right here, 8 times 5, is what will give you the 40 that you need. Now double check. 1, 2, 3, 4, 5 additional zeros. 1, 2, 3, 4, 5. 5 zeros. Yay. So we did it. Okay, so watch out when your first basic fact has a 0 on it, so you can then count the rest of the zeros. Let's do some word problems. There are 19,000. I need water. Okay. There are 19,763 tickets available for a New York Knicks home game. If there are 41 home games in a season, about how many tickets are available for all the Knicks home games? So these are exact, and we need to know approximate. These are your exact numbers, and we just need to know approximately. So I'm going to take this and I'm going to say, nobody really cares about the exact number, bump it up, and then bring this back down a wee bit. And then you've got a quick and easy fact. 2 times 4 is 8. And then you just count your zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Put your comma in to make it easier to read this number. And so you would say, because you have to write about how many tickets are available, about 800,000 tickets are available. I hope these videos are helpful. Click subscribe, come back again. I will try to help you on more videos. Next one, Michael saves $423 a month for college. Wow, good for Michael. About how much money will he have saved after 4 years? We've got a month, and then we've got 4 years. So if we have approximately $423 a month, how many would we have to multiply by to get 1 year? So that's right, 12 months in a year, $423. So we're just rounding because it says about. So I'm going to take this down to about 400. And you can still use the 12. If you have 4, you should know your 12s. That would give us a more exact answer. Okay? If you change it to 10, you'll be a little bit lower. But again, it's estimating. I wouldn't mark it wrong if you changed it to 10. But I would definitely leave it at 12 because that's a better estimate. So, what does this mean? This means per year. But the question is asking about 4 years. So I'm going to take my 4,800 and multiply it by 4, which is approximately 5,000 times 4. Okay, so we're just, again, trying to estimate the whole thing. 5 times 4 is 20, and then additional zeros, 1, 2, 3. And so that's about how much money he would save after 4 years. That's a lot. He would save about $20,000 after 4 years. And that's good incentive. Save your money. Save it for something special. How about part B? Will your estimate be lower or higher than the actual amount Michael will save? Now, how do you know? So go back to the very beginning, okay? When we took off those $23, this is called an underestimate. Okay, so I'm going to say 423 to 400 is an underestimate. Okay, now when we bump it back up, so we underestimate here, but then we kind of bump it up here by a little bit. So initially, our first, so 423, 400, sorry, initially our first is an underestimate. Then when you bump it up here to 5,000, you're bumping it up again by 200 per month. So that's going to get it pretty close. So initially, your first estimate would be lower, okay? Now, if you change it to something else, let's say if you bumped it to 450, that would be an overestimate. So only if you're using this number, you're going to have an underestimate. And so it's about how many times you're repeating it. If you want to know exactly, you can always take the 423 times the 12, get the exact number, and then compare it and really look for yourself and see how close you are. Then compare it to the 5,000 times 4 and see how close that is. But our initial estimate being 423 down to 400, that would be an underestimate. Okay, so I hope this has been helpful, and come back again for more videos on 5th grade math. Bye for now.